Hello, future engineers, subscribers, viewers, and students. Here is another video in structural analysis, particularly on beam deflections. This is given as quiz in my class. For the beam loaded as shown, compute the slope and deflection at A by area moment methods, at C by conjugate beam method, and at E by the double integration method. Although I'll first present the double integration method, and from that method, let's also compute the slope and deflection at A, at C, and of course at E. Then let's also solve this slope and deflection by the stated method to be employed. So first, these are the reactions, summation moment about V equals 0. So as structural engineering or structural analysis, as students in structural analysis, you should be able to find these reactions, or else if you're not suited to be students in structural analysis, if your problem is still on reactions. So that's the first step. So these are the reactions. Therefore, the equation, I have to extend this load 20 kilonewton per meter up to this, then counter it with the same load so that the moment equation is applicable for the entire span. So EIY double prime equals 47.083 times, of course, the x is from A to that section there, so x minus 2, then plus 137.917 times, this is x, so x minus 14, then plus 20 times x minus 2 times x minus 2 over 2, so that's 10 quantity x minus 2 square, then minus 20 times x over 2, so minus 10x square, then minus 15 times quantity x minus 9 times x minus 9 over 2, so that's minus 7.5 x minus 9 square. Integrating once, so EIY double prime equals 23.5415 x minus 2 square plus 68.9583 x minus 14 square plus 10 thirds x minus 2 cube minus 10 thirds x cube plus minus 2.5 quantity x minus 9 cube plus c sub 1. Integrating again, we have EIY equals 7.8472 x minus 2 cube plus 22.9861 quantity x minus 14 cube plus 5 over 6 x minus 2 to the fourth minus 5 over 6 x to the fourth minus 5 over 8 quantity x minus 9 to the fourth plus c sub 1 x plus c sub 2. Let's now reinforce the boundary conditions. When x is 2 and when x is 14, y is 0. So first at 2, so 0, 0, 0, 0, 0 equals negative 5 over 6, 2 to the fourth plus c sub 1 times 2 plus c sub 2. So setting up the equation, 2c sub 1 plus c sub 2 equals 40 over 3, call that equation 1. Then when x is 14, y is 0. So 7.8472 times 12 cubed, then plus 5 over 6 times 12 to the fourth, minus 5 over 6, 14 to the fourth, minus 5 over 8, 5 to the fourth, plus c sub 1 times 14 plus c sub 2. Simplifying equals 0. So simplifying 14c sub 1 plus c sub 2 equals 1564, equation 2. Solving equations 1 and 2 simultaneously, we obtain c sub 1 equals 129.222 and c sub 2 is negative 245.111. So c sub 1 divided by EI is the slope at A, and c sub 2 over EI is the deflection at A. So 129.222 over EI, 200,000, this is in radians, then times 180 degrees over pi. In degrees, theta A is equal to 0.03702 degrees. And delta A, negative 245.111, we simply divide that by 200 to convert that to mm. So delta A is negative 245.111 over 200. In millimeters, that's negative 1.226 mm. So when x is 9, let's solve for the slope and deflection at C. So EI theta C equals 23.54157 square plus 10 thirds 7 cube minus 10 thirds 9 cube plus C sub 1 129.222. So theta C is equal to negative 3.9112 over 200,000 radians times 180 over pi. So theta C is equal to negative 0.00112 degrees. Then delta C rather, substitute into this equation, x is 9. So EI delta C is 7.8472 times 7 cube plus 5 over 6, 7 to the 4th, minus 5 over 6, 9 to the 4th, plus C sub 1, which is 129.222 times 9 plus C sub 2, negative 245.111. So delta C is equal to 142.81 over EI. EI, we just divide 200 to convert that to mm. So delta C is 0.7140 mm. Finally, when x is 17, to solve for theta E by double integration method, this is the official solution. So EI theta E is equal to 23.5415 times 15 square plus 68.9583 times 3 square plus 10 thirds times 15 cube minus 10 thirds 17 cube minus 2.58 cube plus 129.222. So theta E is equal to, take note that these are the equations derived from the preceding slides. And let's solve for theta E and delta E in these slides here. So that's EIY prime. We just copy. And EIY. So this is the expression for EIY. So let us continue with theta E. So EI theta E is equal to 23.5415 15 square plus 68.9583 3 square plus 10 thirds 15 cube minus 10 thirds 17 cube minus 2.58 cube plus 129.222. So theta E is equal to negative 0.1031 degrees also, because its value is negative 359.982 over EI, then times 180 degrees over pi. Then EI delta E is equal to 7.8472 times 15 cube plus 22.98613 cube plus 5 over 6 15 to the 4th minus 5 over 6 17 to the 4th minus 5 over 8 8 to the 4th plus 129.22 times 17 plus negative 245.111. So delta E is negative 916.746 divided by 200 to transform that into mm automatically. So delta is negative 4.584 mm. So these are the official values of theta E and delta E. So by double integration, the solution will be shortened by proceeding directly to these solutions. Let's just use the double integration method to check our answers for theta A and delta A by area moment method and theta C and delta C by the conjugate beam method also. So EI division of D relative to B is equal to 1/2 of 12 times 565 times 4. So we sum up moment here. Minus 12 times 40 times 6. Minus 1/2 of 12 times 480 times 4. Then minus 1/3 of 5 times 187.5 times 5/4 or 1.25. So solving division, EI division of D relative to B is negative 1 to 30.625 over EI. So negative means D is below the reference tangent at B. This is the figure and this is division of D relative to B. But the slope at B is positive because it is inclined up to the right. So theta B is positive, absolute value of this value divided by 12. So theta B is 1230.625 over 12 EI. So theta B is 102.552 or 552 over EI. Having found theta B, so this is the tangent, that's also theta B. So this is 2 theta B. Let us compute this division of A relative to tangent at B in order to solve for delta A and in order to solve for theta A. So for EI, theta AB, it is just 1/3 of 2 times 4p, this area here, negative 40. So it is negative 80 over 3 EI. So this is negative, so it is clockwise. So this is the tangent at A, then the tangent at B, this one. So that's why you have theta AB. That's the direction, that's clockwise because this is negative. But this is treated positive here. And this is theta B. The angle that the tangent at A to the horizontal, the tangent that A makes with the horizontal is theta A. And that is positive from the figure. Therefore, theta A is absolute value of theta AB plus absolute value of theta B. So theta A is positive, absolute value of theta AB plus absolute value of theta B. So theta A therefore is 129.219 over 200,000 times 180 degrees over pi. So theta A is equal to 0.03702 degrees, which is the same as the answer before. Then for delta A, we have to compute division of A relative to B. So theta A is 0.037. So to continue, let's solve division of A relative to B, EI division of A relative to B. Just the moment of this area, 1/3 of 2 times negative 40 times 3/4 of 2. 3/4 of 2 is 1.5. Or 3/4 of 2 is 3/2 or 1.5. So division of A relative to B is negative 40 over EI. Negative means point A on the elastic curve is below the reference tangent at B. So it is correct in this figure. Delta A therefore is below the horizontal. So delta A is negative. It is the negative of absolute value of 2 theta B plus absolute value of division of A relative to B. So delta A is negative quantity 2 times theta B, which is 102.552, then plus absolute value of division of A relative to B, so 40 over EI, then make it negative. It is equal to negative 245.104 over 200. So delta A is negative 1.326 mm. Then for C by for E by uh, conjugate the method. So theta C by conjugate the method also. So that's all for theta C, theta E and delta E by conjugate beam method. So this is theta D. Summation moments about, let's consider BD. Summation moment about B equals 0. So 1/2 of 12 times 565 over EI times 8 moment arm equals theta D times 12 plus 12 times 40 times 6, 40 over EI times 6 plus 1/2 of 12 times 480 over EI times 8 again, moment arm, then plus 1/3 of 5 times 187.5 times 12 minus 5/4, that's 10.75. So this is 5/4, so the distance of the centroid from B is 10.75. So solving for theta D is equal to negative 179.948 over EI. Then having found theta D, considering DE, summation forces Y equals 0. So negative 179.948 equals theta E plus 1/2 of 3 times 75 over EI plus 1/3 of 3 times 67.5 over EI. By the way, this is 67.5. First, 25 times 3, so 75 over EI. Then, uh, 15 times 3 times 1.5, 67.5 over EI. This is second degree. 47.083 times 12, so we get 565 over EI. Then this is 20 times 2 times 1, so second degree 40 over EI. Then we just extend it. That's, imagine we have a couple here, 40 over EI. Then we have a force of 40 kilonewton downward, 40 times 12, so that's why you have 480 over EI. Then 15 times 5 times 2.5, second degree 187.5 over EI. So that's the explanation for the preparation of this moment diagram by parts. So let's go back to this. Theta E is equal to uh, negative 0.1031 degrees. It is equal to negative 359.982 over 200,000 over EI times 180 degrees over pi. So that's why theta E is negative 0.1031. And summation moment equals 0, delta E plus 1/2 of 3 times 75 times 2 plus 1/3 of 3 times 67.5. 3/4 of 3 is 9 over 4. Then equals theta D, negative 179.948 over EI times 3. So solving for delta E is negative 916.719 over 200 over EI. So the shortcut is we just divide by 200 to convert that to mm. So delta E is negative 4.584 mm. So that's it for this video. And lastly, for the slope and deflection at C by the conjugate beam method. So let's consider BD, and we sum up moments about B equals 0. So we have theta B times 12 plus 1/2 of 12 times 565 over EI times 4, then equals 12 times 40 over EI times 6 plus 1/2 of 12 times 480 over EI times 4 plus 1/3 of 5 times 187.5 over EI times 5/4. Solving for theta B is equal to 102.552 over EI. Then knowing theta B, let's consider BC. So in BC, summation forces y equals 0. Theta B 102.552 over EI plus 1 half of 7 times 329.581 over EI equals 7 times 40 over EI plus theta C plus 1 half of 7 times 280 over EI. So these areas. Theta C can now be computed. It is negative 3.9145 over EI, which is 200,000, then times 180 degrees over 5 to convert that to degrees. So theta C is negative 0.000112 degrees. Then delta C, summation moment about C equals 0. So we have delta C plus 7 times 40 over EI times 3.5 plus 1 half of 7 times 280 over EI times 7 thirds equals theta B, which is 102.552 over EI times 7 plus 1 half of 7 times 329.581 over EI times 7 thirds. So solving for delta C is 142.776 over EI, and EI just put 200 to convert that to NN automatically. So delta C is 0.7139. So that's it for this video.